welcome to Data Science Club number 21. Last week we talked to one of the folks in our class and they said, hey, can you guys do anything about... Oh, I turned this off. That's not what I wanted to do. Last week we talked to one of the folks that are here on campus taking our class, and they wondered if we could do anything regarding like the deep fake kind of technology that's going on around lately. And so this week we're doing something related to that. So all of those models are based around something called a generative adversarial network. So that's what we're going to explore today. Any other things you want to add, Ravi?
Basically, so we are, in this tutorial, we are just going to go with a very basic function just to give you guys an idea about what a generative adversarial network, or more commonly known as GANs, is. And the definition is pretty basic, but it should give you an idea, and then you can apply it for your much more complex problems.
And bear in mind, this is the first time that Ravi or I have built a GAN, and so we're going to be following this tutorial and just as excited as you guys are about doing this. Because we've played around with some other code that other folks have written, but we haven't really built one of these models from scratch. And these are the types of models that make people concerned that artificial intelligence will become creative and be able to do stuff. And what you'll see here is it's a little bit more like a really clever police sketch artist. He could generate, the model could generate more things that look like the data it's seen, but it's not going to generate weird stuff.
Yeah, something completely randomly new. It still needs to have some sort of input data that it's going to create fake data out of.
Yeah, I mean, if you fed a GAN a whole bunch of images of, Ravi and I, if we just took pictures of ourselves every time we came to work, then it might generate a picture of somebody that looks something like a combination between Ravi and myself, but we could pretty much be guaranteed it's going to be wearing plaid or a t-shirt. That's essentially what's going on. It's not going to be wearing, a kilt or something like that crazy, because Ravi and I don't do that. So that's not what it's for. So we'll get into it. There's lots of different applications for it, which we can talk about later. So first things first, we're showing a graph of what the overall architecture of this looks like. And really there are two fundamental pieces. So even if you take a look at a graph of a GAN and it's confusing, what I want you to take away is that it's got two pieces, a generator and a discriminator. So what this is it's not one neural network, it's actually two neural networks that are linked together. And this is where it starts to do things that seem really complex and quote unquote imaginative. And what's going on is there's one model whose job it is to take random noise and then turn it into something that looks like data. Or pictures, if you've seen the deepfake kind of stuff. And then there's a second neural network model whose job it is to just try and identify, was this a real data sample or a real picture, or was this a fake data sample or a fake picture? So over time, the generator model gets better at fooling the discriminator, and over time the discriminator gets better at not being fooled by the generator. And so over time, as they get trained, you get better at generating real looking data from one of these models.
One of the best definitions that I've heard for GANs is at a conference, and the basic definition they said was, you have two neural networks that are fighting each other, generator is trying to fool, like William mentioned, the discriminator model, and the discriminator model is like, oh no, you're not, this is not correct. So it's going to give off some values to generator that, okay, next time you have to do better. So it will take some input from the discriminator. It's going to try to build better fake data, and then discriminator is going to take it in again, and discriminator is also going to try to get better that, oh, the last time he gave me this, so it knows how to identify the fake ones. And similarly, so both of them keep fighting each other till both of them get way better.
Yeah, and that's exactly what's going on. I realized we didn't have the chat open in case anybody's trying to talk to us live, which I think up until this point we really haven't had anybody talking to us, but that's all right. So if you're out there and you're watching us, feel free to send us a chat. We have the chat open now, so we should see it.
Yeah.
All right, so we're going to be going over this tutorial from Jason Brownlee on machinelearningmastery.com. If you're searching for it later, you can find it in the comments of the YouTube video, or the description of the YouTube video, or the podcast episode. But this is a really nice example to start out with generative GANs. We'll just say GANs because that's easier than continuing to say generative adversarial networks.
Yes, I agree.
If you can say that 10 times fast, then good on you.
I mean, that's the reason why we use acronyms, because some of these things could get ridiculously big.
yeah, pretty hard to say. All right, so we're not going to read quite through everything. I think it would be a good idea to sit down and read through this to really get a good, deep understanding of what's going on. And if you're really into it, Jason Brownlee has actually written an entire book on GANs with step-by-step tutorials like this one. And so feel free to get his book. Let us know how it is if you do, and we'll see if there's more GAN examples we can do in the future. So first things first, we need a Python environment. So we're going to go to the UAB Chiha resource, which is at rc.uab.edu, and we've gone to interactive apps and started up a Jupyter notebook. And so if you have done some of our tutorials in the past, you know we have a Anaconda environment that we're going to use called Notebook of the Week. And we have this, we're going to go to the directory that we generally keep our tutorials in, which is in our data directory, and then rc-dsc. The other thing important for this example is that you really want to use the Pascal nodes partition. If you're on Chiha, this will give you a GPU, and that will get you to where you can train your model faster than maybe you could otherwise.
And remember, GANs are computationally intensive, so working on a GPU might be a good idea this time. I mean, if you don't have it, work on the CPUs. If you're not on Chiha or anything, then if you don't have an option, use the CPUs. But yeah, if you have an option of using GPUs, you might want to use GPUs, particularly in this case.
Yeah. I already requested a Jupyter notebook, so we're gonna go and look at the one I requested. All right, here we go. All right, so let's make a new folder. I gotta rename it. Let's call it GANs. Then we're going to go inside that folder and we're going to create a new Python notebook, and we're going to make sure that we select the environment that we want to use, which is this Notebook of the Week. If you're doing this on your local machine through your own Anaconda, just make sure that you select your environment before you launch Jupyter, and that will make sure environment that you have. All right, so I'm gonna split off this into two separate windows, I think. All right, so let's make that bigger. All right, and then we'll bring our Jupyter Notebook over here.
I think you can split in back in two now, right?
Yeah, you can. You can if you're full screen. We could do that. There you go. That's pretty nice.
Yeah.
All right. So let's see. So now we're in the tutorial. We're going to start actually doing some code. And so the first thing that we're going to do is define a function. So in order to kind of test out what a GAN does and what it is and how we can use it, what we're going to do is, instead of jumping right into the really crazy example, we're going to jump into something that is a little bit more basic. So instead of doing an image, which is a two-dimensional function, for lack of a better phrase, we're going to just use a one-dimensional function. And in this case, we're going to use x squared.
Yeah, so for people who are hoping that we will do deepfakes, we are going to do it, but sometimes in the future. In today's tutorial, we just want to show you a basic function. And having a basic function, like if you guys can see the tutorial where we have the calculate x, we are just getting this function that's finding the square of the number that you put in it. That gives us a plot where we can see, and it actually helps us in visualizing if the GAN network is going to be correct or not later on.
Yeah, and so yeah, if you're looking at the output, what you'll see is that we have an x squared type curve that we're plotting out. This example is really large, so we're going to gloss over talking about some of the Python specific things we've talked about in the past. Feel free to come into office hours to talk about anything that's confusing you. But we just really want to make sure that we get through this so that you guys can start playing around with one of these examples, because it should be a lot of fun.
Yeah.
So just very quickly, we're importing libraries, we're defining our x squared function, we're creating some input data, calculating the outputs for that, and then plotting it.
I think we copied it twice.
And yeah, it looks like it copied it twice. So we're gonna not do that. All right.
And yeah, this is the basic U function that you get when you are plotting a graph for x squared function. It's basically like at 0, it's 0, at 0.2 and minus 0.2, it's the same thing. So you get a good U-shaped graph.
Yeah. And if we changed it to x cubed, so x times x times x, then it'll look something like this. Maybe we'll try to maintain x times x times x and see if we break the example. That might be fun. All right. So first thing, now we're going to generate. Okay, so now we're going to use the function that we have here to compute what our function is, and we're going to create new samples so we have a lot of training data to work with. But let's just double check that that's what this is actually doing. Okay, it's not using our function that we created, so we're going to alter this so that it does. So what this piece of code is doing is it's randomly generating 100 samples, and then after the samples are generated, it's making sure that they go from negative 0.5 to 0.5. And then after we do that, it's squaring them in this case, and then just reshaping these arrays to make sure that they're the correct shape.
Basically, we are, rather than having that straight line, we are going to have a lot of individual points. Like if in our earlier example, if you would have seen, we were just taking 5 values. that was 10 values, 0.5,
Yeah.
0.4, 0.3.
Yeah, evenly spaced.
Yeah. And now in the next one, we are going to have 100 data points between minus 0.5 and 0.5.
Yeah.
They are still going to follow the same function. So
Yep. And so I've changed it to use our calculate function that we defined in the first block, which will do x cubed rather than x squared. And then let's see, if we run this chunk, yeah, so now we can see our data points. And this is important because when we're training our machine learning, we need data samples to train based off of. And so this function goes ahead and gives us the input data that we need. And so you could specify here that you wanted 1,000 samples or less. And yeah, it's pretty straightforward, I think. All right, so now let's go down. So now we're starting to get into some of the machine learning meat, as it were. So we're going to start by making our discriminator model. And so first thing we got to do here.
Yeah, we might want to actually copy the next one because it has the libraries as well.
Oh, okay. The tutorials on machinelearningmastery.com are really nice to break everything up into small chunks that you can kind of easily digest. But it does mean sometimes you got to scroll down just a little bit further than you were planning on.
Yeah.
All right. So here, what we've got going on is we're building a really simple neural network. And if you've done, if you did the MNIST example from last time, this is an example that's even simpler than that. This would even fall in the category of something called a perceptron, because we really only have 2 layers for this neural network. So we have one densely connected neural net layer that has 25 nodes, and then another layer that has 1. And so this first one is just taking in our input features and then trying to categorize them. And then the second layer takes the aggregation of those 25 layers, and then the weights on those edges to that last layer help define whether or not it was a true sample or a fake sample. And so we can, all right, so after we define the model, if you use this model.summary function, it will actually tell you, again, what layers were in there, and then this plot model function will actually spit out a graph of the model, so we can take a look at that. There we go. All right, so it's using the TensorFlow backend, which we're expecting. And let's see, still thinking a little bit.
Yeah.
Okay, so there we go. All right, so yeah, so we built a 2-layer neural network here. If we go and look at that image, let's see, I think it's in data user WS Monroe, RC-DSC, GANs. All right, we can view that PNG file. So yeah, so we can see the actual graph of the network. So it's expecting, for input, it's expecting a coordinate.
Yeah, X and Y. Yeah.
X and Y, okay. Yeah, so it's expecting a coordinate, and then at the output, it's going to give us just one number, which is either a 0 or a 1, I think. All right, so that's the discriminator. It's not a terribly complicated neural network in this example.
Yeah, I mean, so however complex you can make the model that we had for finding out what MNIST dataset has, it could be the same thing. I mean, the basic definition is like there are 2 neural networks. in GANs. I mean, they're both competing against each other, but the single neural network might be very similar to how you'll run any CNN or convolutional neural network or something. So
Yeah, no, and that makes a lot of sense. So these discriminator models can really be very similar to the model that we might build to just say, was this a cat or a dog?
yeah,
But primarily, we're always going to be boiling it down to, was this real or was this fake?
yeah,
But it could have the same layers where we have convolutions and dropouts and all sorts of things like that. I suppose you could put the full ResNet architecture
yeah,
in there if you wanted to, but that would make the model very heavy. So that's something you'll have to balance out as you're trying to use these things. The more complicated these models are, the more difficult it will be to train them because it'll take more resources. All right. So now that we have our discriminator, what we can do is we need to create a function that will just generate our sample data. I think I actually have the function up here.
yeah. I mean, they're just renaming it as generate real samples.
Oh, I got it. So the difference here is because now we're going to use it for training and not just plotting, we need to also generate a y vector.
Yeah.
So, all right, again, we're going to change this so it uses our calculate function. Okay. And then what's going on here is, again, we're randomly generating samples, but then at the end, we're creating this y vector, which would be the target or the label that we need for training that final layer of our discriminator function. And then the same thing with fake samples. So this one here, I think this is just generating random noise, right?
Yeah. I mean, initially it will start creating any kind of random. I mean, that's why the function is like x1 equal to -1 plus random value of n into 2. So it could be any value that might be generated over here.
Okay. And so it looks like what we're doing here is then we're gonna train the discriminator on this random fake generator. So later we're gonna create another neural network to generate this fake data, but to initialize, we're gonna just create random data to start training our model on. And so let's see. I guess we want to copy this whole chunk because it has the libraries. But let's see. We'll just copy this other piece up here and then add what we need. Okay. All right. So this train discriminator function says, okay, we're going to need to go for 1,000 epochs, which is look over our data. Each epoch is one time of looking over all the data that we have.
Mm-hmm.
And then what this is doing is saying for each epoch, we need to generate a half batch of real samples, a half batch of fake samples, so that we have an equal amount of fake and real samples, and then we're going to train on that batch. In each case, we're going to train half with the real stuff, and then we'll train on the second half batch of the fake stuff, and then compare our accuracy against the real versus the fake. And so let's see. So in order to run this, at this point we've just created functions, so we just have to call those functions. So we just have to define the discriminator and then train it. So let's see if this works or if it breaks. All right. Okay, so this is where we ran into, we didn't have our libraries defined. So let's just snag the library definitions, and we'll put that just up at the top to make sure all of, oh my goodness.
Command C. Oh.
It was the copy paste somehow added a whole bunch of numbers. All right, so now we have imported all the libraries we should need. So if we go back down and rerun that define discriminator, train discriminator, it should work.
Yeah.
All right, let's see. Still thinking. All right, and that looks like that's powering through pretty fast. So you can see at the beginning, the accuracy is about 50-50.
Yeah, for the real and fake one.
For the real and fake ones. And then as it goes on,
surprising result.
It's getting...
It's still very random. Apart from it's very easily able to find out if it's fake or not. The fake accuracy is pretty high.
It's doing better at about 400 epochs, it's starting to converge where it's doing a pretty good job of telling both. But it is interesting to look at these numbers because it can tell which one's fake before it can tell which one's real. So that's actually pretty interesting. So it can basically say like, yeah, that looks like random noise before it can say that looks like it's fitting into a function.
What's the last at the 1000th epoch, or 999th epoch?
Yeah, so at the 999, it made it so we got 92% accuracy to tell whether or not it was fake, and we're 100% accurate on the real samples.
Yeah, I mean, it could have kind of overfitted, I guess. I mean,
it could have overfit, but we're also just modeling an x to the third function.
Yeah. So this function is so simple that it might be easier for it to find.
Yeah, and this is one of the things that when we went to PERC was interesting that folks started to mention of using neural nets to model functions. In some cases, you get performance boosts, but certainly in situations like this, you might not get a performance boost, but a neural network has a lot more parameters than an x to the third function does. Mm-hmm. So it would make sense that we should be able to model that pretty accurately.
Yeah.
All right. So now we've got to look at...
Yeah, so I mean, we have a discriminator model now, and it seems to be doing pretty well. I mean, 92% in identifying fake is pretty decent, I would say. Alright, so the next one is generator model.
Mm-hmm.
And if you remember from when we began this tutorial, generator model is the one that's going to start creating fake data points now.
Yeah, and at this point, on our first training of our discriminator, we used a really stupid generator, which was just random numbers.
Yeah, and that was mostly to train our discriminator to have some idea about what fake data would look like.
Mm-hmm. Yep. And so now what we're going to do is we're going to define our generator. And again, it's going to look
very simple.
Very simple. But in this case, if we look at this, all right. So what's going on here is we're going to feed this generator a vector of random noise, and then we want it to spit us out the XY coordinates that would correspond to a real point.
Yeah.
So if we were trying to use this for images, our input and our output might have the same size because we would run through some convolutions to create something that looks like a real image, and so that's what we would run our output. In this case, we just have we're just looking for a set of coordinates.
Yeah. So that's why the number of outputs is 2, and that's the final output that's going to be returned from this model. So.
Yeah, and so again, you can see it's a very simple model. We're just doing a another 2-layer network. In this case, we're having a layer with 15 nodes and then a layer with 2 at the output. And so that's our generator model. And so now if we, all right, so we've got to, again, I don't think we have to re-import these things because we imported them.
And we already defined the generator, so we just need to do that last part.
All right. So now we're just going to copy this last part of the function.
He's using the word model a lot.
He is using the variable model a lot. It's it may bite us later. We'll find out. In general, best practice would be to label these models differently, just so that you don't get confused as to which one you're looking at.
Yeah.
Actually, let's just. We won't worry about it today. This is a complicated enough example. We'll just follow along, make sure we don't miss anything.
Yeah.
But even just calling this like G model and the other one D model would help separate them out. All right. So again, we've defined our model. We've told it that we want an input random vector of 5, and then we have the model summary, which shows us where our layers are. And if we looked at the output image that's spit out here, we would have a graph of what our network looks like.
Yeah, and it should be pretty similar to how our first one looked like. So.
Yeah, right. It's in the article.
Yeah, good.
Yeah. All right. So now what we're going to do is, so we're still creating our generator model. So we have to make a function that's going to create the random input variable, or the random input vector, I should say. And then the next thing we got to do is to generate fake samples. And so again, in this case, what it should be doing is, well, let's see what it's actually doing before I tell you what it should be doing. All right, so we're using the previous function to generate the random input vector, and then we're using our neural network model that we created, the generator model. So it would have been nice if we called that model generator up here, just for keeping things together. But basically this generator here, I believe, is the generator model. And then what's happening here is we're predicting based on that random noise, and then we're going to show the results where X would be the, in this case, X is just a set of samples that are coordinates. All right, so let's do that, and then we've got to call all those functions and actually see how they're doing. Okay, so at this point it's random noise, which we would expect. So the nice thing about the way that we have this set up is we should be able to swap out the generate fake samples from the previous function with this one. I think that's where we're headed. All right, so it looks like he's saying we should train our generator now. All right, so let's... I think this is actually training the whole GAN at this point.
Yeah, because we have a generator and a discriminator models now.
Okay.
And we are just adding both of them at the same time now.
Okay, that makes sense. All right, so now we're going to define the GAN. Okay. All right, so defining the GAN means we're going to take in our generator model and our discriminator model, and we're going to piece them together, and so that we can actually see what's what. All right, so it looks like Oh, okay, interesting. All right. So what's going on here is we've already trained the discriminator to notice what random noise looks like. And so he's declaring that the discriminator to not be trainable. So we're saying freeze the discriminator, don't let it be retrained in this version right now.
Yeah.
All I want to do is train the generator.
Yeah, I mean, and it should be very simple to understand, because right now you have a discriminator that's able to identify fake and real data, and if you allow that to be trained as well, then it's going to get in some values from generator data, and it's going to be like and if the discriminator also gets trained, then it would have more samples of the fake data, and it might try to shift its accuracy towards the fake data. So that means that its predictions of whether it's fake or not might not be reliable after that.
Yeah. So we'll just have to see how this works. But again, I think because we've frozen the discriminator, essentially all we're doing is training the generator piece. So now we can call our functions here. So we'll just pull in this last piece. All right, so again, we've defined the latent dimension, so how big we want our random vector to be. We're creating our discriminator, creating our generator, and then creating our GAN model, which this function also freezes our discriminator. So let's see that. All right, so you notice that when I say the model summary, it's telling me I have two sequential models. One has 122 parameters, one has 101, and the shape is 2 and 1. If I go up here to the generator, I can see that I have 122 parameters and shape is 15 and 2. And so what's going on is, because we're using the sequential API with keras, it's not showing us what's inside of here.
Yeah.
If you use the functional API, it'll actually show you what model is inside of those different pieces. But just make sure you double check these parameters and see that they at least match the models that you brought in. So we put the generator in first, and it has 122. We got 122.
I wonder how the PNG file looks. Is it the same? The GAN
that's a good point. Let's look. All right, so we're going to look at the GAN plot.
Yeah, it shows the same thing, the sequence.
Yeah, and if you use the functional model, it would look more interesting because you'd actually see what layers are present here. And then you notice here we have non-trainable parameters that match how many we have in our discriminator.
Yeah.
All right, so let's see. All right, so we just defined the GAN, but we haven't actually trained it. So now we're going to create another function to train the GAN. Well, at this point, we're really just training the generator. So we're going to create a function, and in this one, we have two pieces here. We have we have the number of epochs, the number of elements in a batch, and here we're going to create an X data set that is generated from the generator, and then we're going to create a Y data set. All right, it says we need to create inverted labels for the fake samples. Okay. I guess that's because we defined fake as 1 and real as 0.
Yeah.
And then we're gonna train with. Oh, I think it's because we actually are wanting. I don't know. I got to think about that a little bit, because if we go back up to this training of the discriminator, we did actually say that the zeros.
Yeah, would be.
Yeah, so what we're doing here is is saying that we're training for the behavior where the discriminator says that this fake sample is a 1.
Okay. Yeah.
Okay, so this is a little bit of a head scratcher, and I'm not sure I'm right. And so if you know more than we do about GANs, feel free to chip in. And if you don't, feel free to chip in too. But basically what we've done is, so we've frozen the discriminator. And so it should tell us that something is a 1 if it thinks it's real, and a 0 if it thinks it's fake. In the middle of all that, we have our X data set should be just random noise.
Yeah.
And so what we're trying to get at is we want a model where we have to change the weights of our generator so that we will create a situation where the discriminator thinks that it's seeing a real sample. And so this is specifically the part that's saying, let's go ahead and try to fool the discriminator.
I mean, it's basically the whole point of the exercise is to create a model that's going to create deep fake data sets for you that's going to resemble the original ones, and that's what's happening over here.
Yep. All right. And then all right, so that's if we wanted to train it. All right, so now he's got a different version of the training function that I think is the one we're actually going to use. So we're going to copy that and paste it in here. All right, so here, all right, yeah, so this basically just adds this portion of training the GAN to the overall training data set, or training function that we created earlier. All right, so now I think we can just scroll down and snag the full chunk of code, because at this point it's kind of becoming a little convoluted what's what. So let's grab the whole example. Nope, that didn't work. All right, so we're going to grab the whole example. We'll put it in here. All right. All right, so we're importing our libraries and then defining our discriminator, defining our generator. So these are just the simple neural networks that we've seen earlier.
Define the GAN.
Define the GAN. So this is connecting the discriminator and the generator. And it looks like what's going to happen is that when we're training in the context of the GAN, the discriminator is not going to get any better. So it's kind of training a little bit at a time. But when we're training in the context of just the discriminator, it will get better. So we'll see what that looks like later. We have a function for generating real samples. So let's change this to our x to the third function. And then we're generating the latent point. So this is the random noise vector that's going to feed into our generator.
I think it defines the space in which the random values have to be generated.
Yes. So it takes in
if
a dimension of 5.
So it's going to be -5 to 5. It's going to give random values.
So I think, I could be wrong, but I think the latent dimension is just saying I want a vector of... no, you're right. I'm pretty sure you're right. Reshape into a batch of inputs. So latent dimension and then random, and then we're reshaping it. Oh, okay, so it's using that for both things. Yeah, so you're right. So it's saying that I want a random number. Is this the seed? Or I can't remember the rand end. Is that how many I want? Oh, that's how many I want. Okay. So it's saying that I want 5 times n random samples.
Yeah.
And then it's going to reshape that vector to be a 2-dimensional array that's n by 5. Right?
Yeah.
Okay.
And then we have generate fake samples.
So that takes those
latent.
5, so those latent points, or that 5 by n vector, and feeds it through the generator to predict, and then creates the appropriate label, which is zeros.
Yeah.
Okay.
Yeah. And now, so in the generate fake samples, we have 2 parameters, x and y, that are being returned.
Yeah. All right. And then, why is this red?
Which one?
This comment. That seems weird. We'll see.
Yeah.
There may be something weird going on here. All right. So then he's got a function in here that's just summarizing the performance. So evaluating the accuracy of the real data versus the accuracy of the fake data, and how good the discriminator is at seeing those things. And then here, and for some reason our comment turned red, so in our Jupyter notebook, so we may have an error somewhere in here we'll have to track down. But then basically we have a training function which is the same as the initial training function, except there's a little bit added. So all right, yeah, this is what I thought was going to happen. All right. Okay. So just like earlier, we're going to divide into half batches. So we're going to train first we're going to train the discriminator on a half batch of real and a half batch of fake, where that half batch of fake was generated by the generator. So basically we're taking in real and fake data, we're training the discriminator. Then we're freezing the discriminator inside of the GAN, and then we're going to generate a whole batch of fake data from the generator.
Yeah.
Oh no, actually we're generating a whole batch of random vectors.
Yeah, it's just for the x values of the x fake values.
This is the x vector for the generator. So these are just the random.
Okay.
I think this is just because the latent dimension is 5. So this is just saying, okay, I want a batch of random noise that's 5 by however many samples I spit in there.
Mm-hmm.
In this case, 5 by 128. And then I want to train my generator to say that those, to make it so that the discriminator says that those are ones.
Okay.
So this is where it gets tricky. So the first part makes sense. I'm training my discriminator to say this is real, this is fake. Then the second part is I've frozen my discriminator, and now what I'm doing here is I'm training my generator to fool my discriminator.
Yeah.
And that's what this train on batch here does. And so you do have to iterate this, because you can't just fully train one or the other. You have to do them in shifts, so that it's at least more clear what's going on. And maybe when we get to more complicated examples, there's better ways of doing this. But even on this relatively simplistic example, that's kind of a puzzle. All right, so now that we've defined all those functions, it's relatively easy to go ahead and call them. So we're just saying that we want our noise vector that we're feeding to our generator to have a dimension of 5. And then we're defining the discriminator, so creating our discriminator model, creating our generator model, creating our GAN model. And again, this is important the way this works, because when we create our GAN model, inside of the GAN, the discriminator is frozen, but up here, when we're just training the discriminator is not frozen, so it can continue to get better. And then here with train, we're doing that whole dance of giving the discriminator fake and real data. It's getting better at recognizing fake versus real, and then freezing our discriminator, and then the generator's taking a turn trying to fool the discriminator. So let's run that and see what happens. Let's see. All right, user warning. Okay, so this is after 2,000 epochs.
Yeah.
Which, compared to what he's got, that looks
pretty
similar.
Yeah. It is not doing bad.
And then after 4,000 epochs, that's getting better.
Yeah.
And then let's see what's going to happen. I guess it's every 2,000 epochs it's going to spit something out. Okay, so after 6,000, that's getting pretty good.
Yeah. So the red one is the original ones, and blue ones are the fake ones.
Yeah. And at...
I mean, it looks... Yeah.
Yeah. At 2,000, the discriminator was only 50% able to say this was real accurately, and then 3% of the fake data was it able to accurately represent. And then when we made it to 4,000, we get 40% and 60%, and 6,000 it's 60-60. And then at 8,000, this is 1%. Interesting. So suddenly it's having struggles figuring out what's real and what's not.
But it's able to find what's not.
Yeah, so most likely what's going on here is it's just saying everything is fake.
Yeah. Interesting.
Because whatever parameters it had. So now at 10,000, it's gone the other way. So it's saying that, okay, maybe everything is real.
All right. So we did not get the same result as the author got.
No, we didn't get, and it's because of the function that we put in. Now, if we change this to be x squared, so we'll just change this to be x squared and see if it may be because of the hyperbolic nature of what we did that.
But it was very interesting.
Yeah, it was really interesting. Yeah, we broke the example. That's always a good thing to do. If you can get it working right, that's one thing. But breaking it is always good. All right, so here's our random data. So 2,000. Again, it's kind of off one edge.
Yeah, I know. That's.
All right.
4,000 looks better.
Yeah. It's at least moving the right direction.
Yeah. Still better, I guess. It's getting better.
Yeah, it's at least moving in the right direction.
Slower than what I had expected, but...
Yeah. Okay.
This is pretty accurate, but...
It looks like it's filling in on a particular spot. It's not filling in the whole function.
Okay. This one actually looks pretty nice.
Okay, so this is, it looks like part of the problem that we're having is, I think what we're doing with our neural network is we've defined its functions to only be linear.
Mm-hmm.
So I think our problem is our neural network right now might only be able to create a linear representation.
I mean, based on how...
Based on what it's looking like.
Yeah, this one and even the previous one, it looked like it was just trying to find something in a straight line rather than trying to find the curve.
Yeah. Well, in any case, it definitely is the optimization thing is doing what it should, but it looks like there's some issues that we're having with how our network is defining the model. So I'm going to have to go back through this and figure out why it's not actually generating the x squared. And I do not know off the top of my head why it wouldn't be doing that, since we just copied this from his stuff. But we'll have to take a look. In any case, you can see it really is genuinely creating fake data points that are looking more and more like the overall function.
Yeah.
In our particular case, it's only creating a subset of points that look like they could fit on that function. But you can see it's not creating novel points that, somehow represent this, represent a new turn on what this function could do. It's just within the normal distribution of the points that we have, trying to fit its points inside of there.
Yeah. I mean, that's what the fake data is. And now, like, you guys can see even the simplest example in GANs can get really complicated, especially because of the nature where you have two neural models and they're computing against each other. So, but yeah, I mean, go through this tutorial and see. I mean, it's a good read. I went through it a bit and I really enjoyed the content of this tutorial. So
yeah, and if you guys figure out before we do of why our model wasn't creating the right distribution, maybe it's just because of the way it was randomly seeded.
Maybe.
Because this one looks like it's more on top of the network.
I don't know where it went this time.
I kind of overshot. Let's see. We're just rerunning it one more time to see if it'll do better.
It still looks like it's trying to do everything in a straight line.
Yeah, it still doesn't look like it's actually generating the x squared function. It's really struggling. But that's why these things are really complicated.
I mean, it looks like it tends to get a little better and then just completely goes off the chart.
Yeah, it doesn't. It almost looks like it doesn't have enough parameters to genuinely match things. So we'll go back through and see where we broke it, and then we'll either post in the comments or make another video later about what we had to do to fix it.
How many? Oh, after 10,000 iterations. Okay.
Yeah. So we're doing the same number of iterations that he's doing. I'm wondering if somehow it was something I did when I created. All right. I'm just too curious. Let's just create one more Jupyter notebook and we'll copy in the code, because there may be something that we did earlier.
Yeah.
That is for some reason creating a problem. All right, so let's just run that. All right, so now we've just copied and pasted his full code into ours. And if this works, then this will tell us that there was some setting we changed earlier in the code that apparently we should not have.
I mean, I already see that the warning is not here. Oh, it is here.
Yeah, it's still here. So maybe we were supposed to compile these models. Oh, is it not going to actually spit out my...
Yeah, I have to read it.
For some reason, Jupyter Notebooks don't always
show
the plots the first time around.
I've always had issues when I turn on that dark reader theme. But over here it's not. Okay, so this time it's...
Oh, wow.
This one looks better. This one looks like how his example looks like.
Yeah, so that's 2000. All right, so...
There's something that we did earlier.
Yeah, so this is an indication that somehow we messed up the initialization in this model over here, and potentially because, oh, you know what might be happening is it may, because so many of these functions are overloaded.
Yeah.
There's a minor possibility that the Python code's taking the wrong function at certain points.
Yeah, I mean, that was my first guess as well. I would have hoped that since we were just running that cell and we had defined all the functions that it was using, that it would take those ones, but it is entirely possible that it's just taking the ones that it sees from earlier. So
yeah, especially again, I don't know why this comment turned red over here.
How about in the newer one?
It's still red.
Yeah. Interesting.
So that's weird. I don't know why the comment's red.
But it looks like it has given us the right output.
Yeah. Yeah, this one looks like it starts out pretty noisy.
And then it starts converging into how the real data set would look like. And and wherever discriminator says, oh, you are fine, you are fine, you're fine.
Yes. So the moral of the story here is twofold. First, GANs are really complicated, and don't be afraid of asking for help or asking somebody else to take a look at your code and make sure you're not missing something. And the second one is make sure that you have a really clean path to your initializations, because I think that's what's going on here, is that because we have all these functions in the same space, we've polluted our namespace and potentially messed up some things.
Especially in Jupyter notebooks, where it keeps track of everything that you have run till that point.
Yeah, because like here we have a function called generate fake samples, but maybe when this is defined here, this defines summary performance or the train.
Yeah, then it's
calling these functions, but depending on what orders everything's getting called in, if this isn't defined in the right order, it could get really confusing. So just make sure that your namespace isn't polluted. If you're gonna write sample functions, maybe name them sample functions or example functions before, and then this shouldn't happen to you. But
and we are going to come back to GAN networks more in the future, and pretty soon. I mean, this was supposed to be the basic example for deepfake, or the networks that deepfake uses, so hopefully we can come back to images soon.
I know I learned a lot, so well, until next time, thank you guys for participating, and we'll talk to you guys later. So just send us a note if there's any applications you guys want to see, and we're happy to stumble on through them.
See you next time, and we'll try to keep it short next time.